National Institute of Ocean Technology, a technical arm of Department of Ocean Development India, is developing a world-class remotely operated unmanned submersible ROSUB with depth rating of 6,000 meters in collaboration with Experimental Design Bureau of Oceanological Engineering, Russia. Subsystem consists of a free-swimming vehicle, depressor with tether management system, launching and recovery system with integrated active heave compensator, traction winch, desk storage winch, hydraulic power pack, powerhouse, high frequency high voltage converter and control console. The ROSUB vehicle is launched from the mothership by the LAS. During the deployment and retrieval, the heave compensation control is activated to reduce the chances of damages. At the required depth, the ROSUB vehicle will detach from the TMS. The TMS and ROSUB vehicle will have independent communication with mothership USBL antenna for identifying the individual location. The ROSUB vehicle has 7 powerful thrusters for maneuverings, 2 multifunctional manipulators for intervention and sample collection, color and monochrome cameras with light for viewing, multi-beam sonar with forward and bottom-looking transducers for obstacle avoidance and high-precision seabed morphology. Sophisticated integrated navigation system comprising of fins, acoustic positioning system, Doppler velocity log and depth sensor for vehicle positioning. It will also be equipped with scientific sensors, a short coder and water sample collection devices. The acoustic positioning being developed for ROSUB has a unique configuration of high positional accuracy and low deployment lead time. The ROSUB vehicle will be immensely useful for many offshore industries in carrying out surveys of pipelines, cable lines, blowout preventers, Christmas tree equipment and other applications with particular reference to gas hydrate exploration, including analysis of mud volcanoes, gas sweepages, pockmarks, sub-bottom layers and sea bottom activities with respect to flora and fauna. The usage of world-class ROV being developed by NIOT and EDBOE will be multidimensional and will open up new vistas of activity areas in offshore sectors of India. The system will be ready for sea trials by December 2005. ROSUB, a multi-sensor platform for offshore inspection, survey and intervention, a product for submersible and gas hydrate group, NIOT. National Institute of Ocean Technology, a technical arm of Department of Ocean Development, India is developing a 2,500-meter depth-rated remotely operated coring device called Autonomous Coring System. Coring system consists of drilling tubes, retractable platform, launching and recovery system with integrated active heave compensator, traction winch, deck storage winch, hydraulic pumps and drivers, powerhouse and control console. The coring system will be launched from the mothership by the launching and recovery system called LAS. During the deployment and retrieval, the heave compensation control is activated in LAS for better positioning of drilling and coring devices. Entire system will have communication with the mothership USBL antenna for identifying the position. Coring and drilling operation will be monitored from the mothership using the fiber optics communication through umbilical cable. The coring system has three powerful thrusters for positioning, three legs, drilling tubes, hydraulic pumps and drives, core barrel and collectors, color and monochrome cameras with lights for viewing. The three hydraulic operated legs are provided for stability, leveling, grouting and conduit for mud flushing. The coring system will have geophysical logs such as density log, resistivity log, porosity log and sonic log, dielectric log and sends online data pertaining to the geophysical properties of sub-bottom layers during the coring and drilling operation. The coring system will be immensely useful for many offshore projects in carrying out multiple coring and drilling on target area, and this includes ground truth validation, qualification and quantification of gas hydrate occurrences, storage of core samples. This coring system for gas hydrate is first of its kind, which would have capability of drilling up to 50 meter initially, which would be upgraded to 150 meter subsequently. The usage of the coring system developed by NIOT will be multidimensional and will open up new vistas of activity areas in offshore sectors of India. The system will be specially designed and equipped for gas hydrate exploration and is expected to be ready by the year 2008.